Okay, so our last section we're going to look at for chapter 9, this is going to finish up conic sections, is part 3. Again, it'll be out of a different book in the homework, so just make sure you follow the PDF in Schoology. But it's on hyperbolas. So when we start out with a conic section, I always give you the definition, and then I show you a picture. Well, the difference in the definition of an ellipse and a hyperbola is one word. That's it. Change one word, and you have a different definition. For an ellipse, you measure the distance to two fixed points, added them, and it came out to a constant. With a hyperbola, we're going to measure the distance to two fixed points and subtract them. So it's a collection of points in the plane, meaning it's a 2D shape, such that if you measure the distance from a point on the hyperbola to a fixed point and then to another fixed point and subtract those two numbers that you get, it will always be a constant. What particular constant, I don't know, depends on the hyperbola. But for a given hyperbola, it will always be the same. Right, so what I'll do after everyone copies that down is I'll bring up a sketch where I can kind of interact and move things on it, and then you'll see what I mean. So we're measuring the distance from two fixed points. In the picture that I'm bringing up, the two fixed points are C and B. Those are my fixed points. E is a point that I can drag anywhere along the branches, that's what they're called, the branches of this hyperbola. So these two numbers up here are going to change. But when you subtract the two, it's always, and you take the absolute value, it's always going to come out to 5.66. If I didn't take the absolute value, it could come out to negative 5.66. Right? Subtracting them will always result in 5.66. Okay, so watch as I drag it, put it in a different spot. So there's an example, 2.46, 8.12. If you subtract those two numbers, you get 5.66. Okay. So drag it over here. Take this point, put it on the other branch. No matter where I drag that point, these two distances will change. But the difference of the two distances never will. 11.56 minus 5.9 is 5.66. So that's what makes something a hyperbola. So a subtraction between two distances always comes out as a constant. And does anyone have a guess what points B and C are called? What were they called yesterday when we did the ellipse? Yeah. So the vertices were 2 points we talked about, but those were the ends of the ellipse. The 2 points that we measured the distance from yesterday were in the ellipse. They were like inside it. Yeah?
Was it the focus?
Yeah, they were the foci. Those were the 2 points that if you wanted to make an ellipse and you had like a board, you could put 2 screws in the board and then take a loop of string, wrap it around the screws, pull it tight, and draw it. And you get an ellipse. Okay, so those are the foci. That's the same name here. Those 2 fixed points are the foci. I think we had the same term yesterday. If you draw a line through the foci, that's called the focal axis. So here's your hyperbola. Here's your two foci. Here is the focal axis. It goes on forever. Okay. If you look at F1 and F2 and you find the midpoint between those two, you get a point about right there. Anyone have a guess what you would call the name of that midpoint between the two foci?
The center.
Yep, that's the center. That's exactly the same definition of center as a hyperbola, as a ellipse. So it's the midpoint between the foci. Now, this is the only conic section that's actually two separate pieces. Every other conic section you can draw just by putting your pencil down, sketching it, and never lifting it. A hyperbola, you can't do that. There's two parts to it. The two parts either look like this, or they look like that. Those are the two cases. Those parts are called branches. So you either have a left and a right branch, or a top and a bottom branch. Now, if you have, let's say, a left and a right branch, and you draw your focal axis. Remember, the focal axis, you can remember it's called that because it goes through the foci. Here's the focus. Here's the focus. Does anybody have a guess what the name for the point is here and there? It's where the focal axis crosses the branch of the hyperbola. Yep.
Vertices.
Those are the vertices. Yep. V1, V2. So the point of intersection between the branches of the hyperbola and the focal axis are called the vertices. Now, if you look at an ellipse and you look at a hyperbola, it's exactly the opposite. Today, the vertices are inside the foci. Okay, the vertices are inside the foci. Look back at an ellipse from yesterday. The vertices are outside the foci. So it's exactly the opposite. Now, there is a name for this. Yesterday, we called that the major axis. It was the segment of the focal axis that went through the length of the ellipse and stopped at the endpoints of the ellipse. Well, this segment that connects the two vertices is a small segment of the entire focal axis. That is called the transverse axis. So it's a small line segment on the focal axis that connects the vertices. And you're going to see today that A and C are exactly the same things they were yesterday. A is the distance from the center to the vertex. C is the distance from the center to the focus. So, that's your hyperbola. And that's your center. And that's a vertex. And that's a vertex. The distance that I just drew in blue is A. A is the distance between the center and the vertex. Here's the distance the other way. Each one of those blue line segments has a distance of A, which means the total length of the transverse axis is A plus A, which gives me 2A. question on the term so far? So we've got one more axis to talk about. So the focal axis is the one that's horizontal, and the transverse axis is the part that connects the two branches. If you draw a line like this, perpendicular to the focal axis, that's called the conjugate axis. So the conjugate axis is a line segment that's perpendicular to the focal axis and goes right through the middle of the branches. If your branches looked like, how did I draw it up above? If they looked like this, that would be your focal axis. This would be your conjugate axis. And not really, I'm not concerned about this last statement really, but the length of the conjugate axis is 2b. Yesterday we called this the minor axis. So it's the same ideas, it's just different names. Conjugate axis is taking the place of the name minor, and transverse axis is taking the place of major. But it's the same concepts. And there's one other thing that comes up when we talk about hyperbolas. And I'm not going to write it down yet. I just want to give you a hint and see if you can figure out what it might be. Anyone have a guess what the other thing is that's going to come up when we deal with hyperbolas? Yep. Asymptotes. Asymptotes. And the asymptotes are what are really going to allow us to draw a very nice picture. They give us kind of a boundary of where we need to stay. You'll find your two vertices, and once you know those, if you have to draw your hyperbola, you just stay very close to that line, curve away from it, and start getting very close again. Same thing over here. So we have to figure out, how do we find these asymptotes? They have a slope and they have a y-intercept. So we'll figure that out. But that's the only thing that's going to be new today, finding the asymptotes. And I'm going to go over the asymptotes right now. Okay, so as always, we're going to start with the case where everything is at the origin. You'll know when it's not at the origin, just like you knew when it was an ellipse. You have a plus or a minus and you have a number in the top. It's going to be the same thing. But we're going to start out with it at the origin. The foci are still going to be c units away from the center. The vertices are going to be a units away from the center. That's the same as yesterday. And this is going to be the case where the transverse axis is horizontal. If you get confused, like, wait, which one is the transverse again? This is the way I think of it. Transverse connects the two. And if you think of transverse, transverse looks kind of like the word traverse. If I asked you if you have to traverse something, traverse means to go across. Like you have to traverse the canyon. You're going to go from one side to the other. That's what the transverse axis is. It goes from one branch to the other. Traverse. Transverse. Okay, that's how I remember. So what's different about this equation compared to an ellipse? It's almost exactly the same thing. There's really only one thing that's different. Yep.
The picture is like, it has two branches and it doesn't just connect. Oh wait, are you talking about the picture?
No, not the picture. Talking about this. Yeah?
It's minus.
Yeah. This is a minus instead of a plus. That is the only change you need to make for this to be a hyperbola. What about here? What's different on the right? Yeah?
You're adding the b squared instead of subtracting.
Right. It's now c squared equals a squared plus b squared, where yesterday it was a squared minus b squared. Now, before we go any further and talk about the asymptotes, make sure you have this written down. I want to look at the case where the transverse axis is vertical, and I want you to tell me what looks different. Does anyone remember yesterday what switched places between an ellipse that looked like this and an ellipse that looked like that? Yeah?
A and the B.
The A and the B switched places. Okay. Watch what happens here. This is the other case we're going to look at. How does this compare to the other equation you just wrote down? Yeah?
The x and the y flipped.
The x and the y switched. So today, the a and the b are stuck where they are. A is always the first denominator. B squared is always the second. So the way you can tell which way the transverse axis goes is look at this letter. It's the positive letter. There's always one positive letter and then one negative letter. Whatever letter you make positive, that's the direction of the transverse axis. So if y is the first letter, it's the positive. The transverse axis goes up and down. If x is the first letter, then it's the positive, and that means the transverse axis goes left and right. Right? So it has nothing to do with the bigger denominator today. Yep. It's a little bit different than an ellipse. And the other thing is the asymptotes. This is how you find the asymptotes when the transverse axis is horizontal. The asymptotes are aligned, and the slope is b over a plus or minus. So we haven't gone over the slope of the other asymptote, but the other one is going to be a over b. So the way I remember is it's supposed to be b over a or a over b is this. HBA. Horizontal is b over a. When it's vertical, the slope is going to be a over b. That. So HBA, that. That's just how I, vertical is a over b, horizontal, b over a. Question on it? All right, not worried about that. This is what you should write down if you don't have it from yesterday. A is the distance from the center to the vertex. C is the distance from the center to the focus. I don't know why they put absolute value, because I don't think A would ever be negative. Really don't have to worry about A ever being a negative. All right. So really, as far as kind of explaining about hyperbolas, that's it. So now we'll try some examples where I either give you an equation and you tell me all the things, or I'll tell you some of the things and you give me the equation. Okay, so this is find the equation. Either way, whether you have to find the equation or I give you the equation, write down your A, B, and C first. All right, can anyone tell me any of those letters by looking at what's given? Yeah.
Is A plus or minus 2?
Can you tell me what the definition of A is again?
The distance from the center to the vertex. Oh, it's just the negative 2.
So you said it's a distance, right? Can a distance be a negative number?
So just
2. So A is the distance from the center to the vertex. Okay. Can someone else tell me another one of those 2 letters that's left? Yep.
C is 3.
C is 3. C is the distance from the center to the focus. Now, to write the equation, you have to know B. B is the second denominator. How can I get B since I know A and C? Eli?
C squared equals A squared plus B squared.
C squared equals A squared plus B squared. So B squared is 5. Technically, I don't think I need B. Unless I'm going to do the slope of the asymptote, then I need B. So I should write it down. So B is the square root of 5. Let's write the equation. Matt, what's the equation of, on the left-hand side, what does the equation of a hyperbola have between the 2 fractions, a plus or a minus?
Minus.
Yep, it's going to be a minus. And my first denominator is always what today? What's always going to go in this spot in general? Yep.
A squared.
A squared, always. Every problem. A squared is 4. What's always going to go is my second denominator? Yep.
B squared.
B squared, 5. Now we have to figure out where the x and the y go. Graph these points and see which way your transverse axis goes. Whatever way it goes, you want that direction to be the positive letter. In other words, put it first. Okay. So the center is 0, 0. The foci is 3, 0 and negative 3, 0, even though they didn't tell me that. 3, 0, negative 3, 0. Vertices, negative 2, positive 2. So which way do I want my transverse axis to go? Yep.
Horizontal.
Yeah, I want it to go right through all those points. So I want it to be horizontal. Which letter is the horizontal? X or Y? Yeah.
X.
X. So you want the X to be the positive one. You want the Y to be with the negative. And that's your equation. Any question on the equation? Now, let's write down the asymptotes. Y equals plus or minus. What's the formula for the slope when it's horizontal? What goes in the top and what goes in the bottom? Yep.
Plus or minus B over AX.
B in the top, A in the bottom. B is the square root of 5. A is 2. Now, for graphing purposes, it would be helpful if I know what the square root of 5 is. I think it's about 2.2. Let's just write that down. Square root of 5. Yeah, it's about 2.2. So that's just for me to remember when I'm graphing. My rise is 2.2 and my run is 2. Positive or negative. Okay? So I graph that right here. Up 2.2, right 2. Up another 2.2, right 2. And then I did the same thing for the negative. Down 2.2, right 2. Down 2.2, right 2. So I did a couple points. I've got my asymptotes. And the other point you want to make sure you sketch is which one? Which one of these points is the hyperbola going to go right through? The center, the focus, or the vertex? Chris?
The vertex.
The vertex. So make sure you sketch that. 2, 0, negative 2, 0. Now, draw your hyperbola with those branches. Stay inside the X, but go through the black dots. If I make it smaller, it's easier for me to see it. And then have it get closer and closer. And do the same thing over here. Have it start close, move away, and get closer again. And that
Wait, I have a
is
question.
what your sketch should look like.
So I know how we got like the first asymptote, but how did you get the one on the other side?
So it's the plus or minus. So positive means we're going to go up and to the right when we do our rise and our run. Negative means we're going to go down and to the right. So I went rise, run, up and to the right, and then I went down and to the right to get the other one. It's just square root of 5 is kind of an annoying number, so I just made it 2.2. Yep. Okay. Any other questions on the equation or the sketch? And sometimes the branches will be in the top and the bottom part, but you'll know that because you'll look at which letter is positive. The X and the Y would switch places if that's going to happen. All right, now let's discuss this. So 5 things you need to tell me if I ask you to discuss a hyperbola. Center, vertices, foci. Which way the transverse axis goes. Asymptotes. But in order to find all those things, A, B, and C. That's what we want to know first. Okay. Abigail, what's A in this case? 4. Because it's over here?
Sorry, because it's the square root.
Right. A is always the square root of the first denominator. B is always the square root of the second denominator. And Jack, what's my formula to get C?
C is equal to A squared plus B squared. And C squared
C squared is equal to A squared plus B squared. So in this case, C is the square root of 20. And what does the square root of 20 simplify to? I'll actually put it over here. Yeah. Okay.
2 square roots of 5.
2 square roots of 5. Okay. So I always start with the center and the transverse axis. These are the 2 you should start with. Where's my center in this case? Because there's no numbers with the X and the Y. Yeah. 0, 0. When you see a plus or a minus with the X and the Y, then you'll know it's not. But until we do that, the center is 0, 0. Which way does the transverse axis go? Horizontal or vertical?
Should be horizontal.
Why?
Because the X is to the left.
Right, the X is the letter on the left. It's the positive letter. So who cares about the bigger number today? It's all about which letter is positive. It's the X. So now that tells us that everything is left and right of the center. Chris, how many units left and right of the center are my asymptotes? Oh, I'm sorry, are my vertices?
4.
4. So to get my vertices, I use A. A tells me how many units away from the center I need to go, specifically left and right. So Ethan, can you tell me my coordinates of my vertices?
4, 0, negative 4, 0.
Yep. So plus or minus 4, 0. And Matt, how many units away from the center are the foci?
Uh, 2 square root of 5.
Yep. The foci are 2 square root of 5 units away from the center, to the left, and to the right. So plus or minus 2 root 5, 0. Again, when the center is the origin, you're going to be able to use that plus or minus. When it's not, you won't. Oh, asymptotes. Transverse axis is horizontal. What's the formula for slope when it's horizontal? Ethan?
Y equals plus or minus B over A.
Yeah, remember HBA. HBA. Horizontal, B over A. HBA. B is 2, A is 4. So asymptotes, plus or minus, B over AX, and you can reduce that. What is 2/4 reduced to?
1/2.
1/2. And that's everything. Vertices, foci, center, transverse axis, and asymptotes. Okay, any question on that? All right, so we've done a couple now where the transverse axis is horizontal. We'll do one more, and then I want to do where it's vertical. This is like the last one. They want you to discuss it. But what's wrong with it? It's not set up to discuss here. Eli?
It's not equal to 1.
Right, it's not equal to 1. So how would we make it equal to 1? Yeah, Jake?
On both sides of 36.
Yep. So we're going to divide everything by 36. So Casey, I'm going to end up with x squared over how much? Yep, over 4. Minus y squared over, what's going to be in the bottom here, Francesca? 9. And then, of course, 36 over 36. It's the whole reason why we divided it, to get 1. Okay. So now let's go through A, B, and C. Tyler, what's A?
Square root of 4.
Yep, which is? 2. Good. Zach, what's B in this case?
3.
3. And And remember, c squared equals a squared plus b squared. So c squared is 9 plus 4, and then take the square root. So there's c squared. All right, now let's write everything down. Ashley, where's my center?
At 0, 0.
Yep, center is 0, 0. Again, it'll be very obvious when it's not 0, 0. Bailey, transverse axis goes which way?
Horizontal.
Yep, because x is positive, so that's horizontal. So now we know where to base everything off of, 0, 0, and we know what direction to go, horizontal. Jake, how many units away from the center are my vertices?
2.
2, and it's 2 units which way?
The left and right.
To the left and to the right, not up and down. So 2 units left and right is me there. Sarah, how many units away from the center are my foci? Square root of 13, and that's exactly the same direction as the vertices, left and right. And Matt, what's the formula to find the slope of my asymptotes?
Y equals plus minus b over a x.
So it's b over a because it's horizontal. Let's look it up. 3 over 2. There's my asymptote. Positive or negative, 3 over 2x. There you go. That's everything. All right, so let's try vertical. Okay, it's really pretty much the same thing, except now the first number will be 0, and the second number will be the one that has the plus or minus. So this is the case where the foci are c units up and down from the origin. The vertices are a units up and down. And the transverse axis is vertical. When the transverse axis is vertical, the positive letter is y. A squared is still the first denominator, b squared is still the second, still a minus, still a 1. Same relationship with the formula, c squared equals a squared plus b squared. Only thing that changed was the x and the y switched. Okay, so we probably won't go through 3 examples of this one, maybe just 2. And then I'll show you one where it's shift, but the shift is going to work just like an ellipse. Same thing. Now, remember what I said about the asymptotes. HBA. Horizontal is when the slope is b over a. Vertical, think that. When your transverse axis is vertical, the slope with the asymptotes is a over b. And I wrote that down right there. A over b. So any question on how this formula is different than the last one? Or what is different? Any question on that? All right, let's try it. So we'll do, let's see, I've got one discuss, and then we'll do one where I give you the information. Okay, you tell me, what's the first thing I should do to discuss this one? Yeah.
Divide both sides by 4.
Yep. Divide all three of those terms by 4. So you're going to get y squared over 4, x squared over 1 equals 1. Now you're ready to do the a, the b, and the c. Jack, what's a in this case?
2.
Yep, square root of the bigger number. Eli, what's b?
Totally blanking right now. 1.
1. It's the square root of the smaller number, which square root of 1 is still 1. And c is the square root of a squared plus b squared. 4 plus 1 gives me 5. Take the square root. And we'll do all the same stuff again. Find all the things. All right, start with the center. Ethan, what's my center?
0, 0.
Yep, 0, 0. Chris, which way does the transverse axis go?
Vertical.
Yeah, it goes vertically because now the y is first. It's positive. So now that tells us everything is above and below the origin. Okay. Zach, how many units away from the center are my vertices?
2.
2. Right? 2 units. Up and down. So what would be 2 units above the origin? What would be that coordinate? Yep.
0, 2.
And 2 units below?
0, negative 2.
Yep. So 0 plus or minus 2. Okay, so we got the vertices. And now the foci. Tyler, how many units away from the center are the foci?
1.
So we don't use b when we're looking for foci.
Square root of 5.
Square root of 5. We want to use c. So square root of 5 units above and below the center. So there's your foci. And asymptotes. Well, we know it's something like that. But what's the slope when the transverse axis is vertical? Yep. A over B. 2 over 1. So you could just write 2. There you go. Okay, questions on that one? So that's the one where they give you the equation and then you have to describe all the characteristics. I had one where you have to find the equation. Does anyone want me to go through the type where you have to find the equation? Maybe you had something like that on a test. Any concern on how you would do it? I think I have one more find the equation. Let's see. I do have one more find the equation. It's going to be a non-centered, not centered at the origin. But does anyone want to see this one?
Sure.
Okay, so this one, a little bit easier than the last one we're going to do in a minute because the center is still at the origin. They tell you that. We've got the vertex, we've got the foci. What's the first 3 things we should always write down when we're doing this? It's going to become 5 things in a minute. Yep.
A, B, and C.
A, B, and C. Okay. Anyone think they could tell me A from what's up on the board? Yep.
2.
2. Center to vertex. B, you're not going to be able to get with the information that's given. You're going to have to calculate it. But C you can get. What's C? Yep. 3. Center to focus. C squared equals A squared plus B squared. So that means B squared is 5. And that's all you really need. You don't need B unless they want the slope. Then that's part of the slope. But in this case, they're not asking for the asymptote. So let's just leave B at that, B squared. That's all you need. Now write your equation. It's always going to be equal to what number? 1. You're going to have two fractions on this side. What goes between them? Plus or minus? Yep. Minus. They're all going to be mixed up on the test. So my advice would be, I kind of get in a certain mode when I'm doing it. I like to do all the ellipses first, then do all the hyperbolas. Otherwise, if I jump back and forth, I mix up the formula. So that's how I would do it. Do all the same type first, and then go back and do all the next type. But it's up to you. All right, so we got the minus. Let's see, what letter is going to go as my first denominator? Yep.
A squared.
A squared. Second denominator?
B squared.
B squared. Now we just have to figure out which way we want the transverse axis to go. See if you can visualize the points in your head. 0, -3. 0, +3. Which way would the transverse axis go?
Horizontal.
So 0, -3.
Oh wait, vertical.
0, +3. And then 0, 2, and -2. All the things line up vertical. So which letter would you want first?
Y.
Y. There you go. That's your equation. All right, so let's look at the last one. So the only difference in the last one is in the formula. Instead of writing x, you're going to replace it with x minus h. Instead of writing y, you're going to replace it with y minus k. And what are the h and the k? The h and the k are the coordinates, or is the coordinate of the center. So we really don't need to write this whole table down because of the way I've been doing it with you. All of this becomes automatic. Only thing you really have to know is these are now your two equations. Let's see if I can. So it was x squared over a squared minus y squared over b squared equals 1. Now the x is replaced with x minus h. The y is replaced with y minus k. Same thing for the bottom. X minus h, y minus k. And it's exactly the same thing for the asymptotes. This was the equation of your asymptote for horizontal. Y equals, that's going to erase itself. Y equals plus or minus b over a x. That's the old formula for your asymptotes. Replace x with x minus h. Replace y with y minus k. That's the new equation for your asymptote. And you might recognize that. This is point slope. When you make the substitution I just said, usually we write like y minus y1 equals m times x minus x1. That's exactly what point slope is. That's what we're using now. Okay, so even if you didn't write any of this down, just remember this, and you're all set. Change these two things. All right, let's finish up with this one. So, find the equation. So last time I said to you, what are the first 3 things you have to find? Now I'm going to ask you, what are the first 5 things you should find? Just list them off to me. Yep.
H, K, A, B, C.
Yep. H, K, A, B, C. Does anybody see what H is in this case? Yeah.
-1.
Let's look at it. So the coordinate of the center is H, comma, K. So let's look at our center and tell me what's in this spot.
Just 1.
Just one. What about K? Yep. -2. K is whatever number is in that spot. Those are the only 2 extra things you had to find. How about A? What's the distance between the center and the vertex? So, 2. If you have trouble seeing it, you just can't do it without the picture, just make a quick sketch. The center is right 1 down 2. The vertex is right 3 down 2. What's the distance from here to here? 2. So that's A. What about C? What's the distance between the center and the focus? Yep. 3. And B, that's going to be the formula, is C squared equals A squared plus B squared. C squared, A squared plus B squared. Again, we really don't need B, we really need B squared. So what, Casey, what's B squared going to equal? Five. Let's just leave it at that. B squared is 5. Let's, you know what I'm going to do, so I don't have to keep scrolling up and down. I'm going to erase all this. Does everybody have the stuff that was in black? That way I can put my answer right there. Okay. Start with a 1. 2 fractions. Subtraction sign between them. Eli, what's my first denominator?
A squared, so 4.
So 4. Second denominator,
B squared.
which is
5.
5. Now, you do have to think a little bit about which way we want the transverse axis to go. I already drew it. You want it horizontal. So that means which letter do we want positive? Yep.
X.
You want to put the X first, put the Y second, and what letter goes right here? X turns into X minus, yep, H. There's that. And Y turns into Y minus K. So what would I put right here? Yep.
+2.
Plus 2. It's Y minus K. The K is minus 2. And that's your equation. So it's a lot of little things to kind of keep track of. But that's how you questions on how we got anything in that form? All right. So that's homework for tonight, 13 to 16. I think that's matching. And then the 17 through 41, that's like what we did in class. So tomorrow we should be able to finish up everything we need to for the week. And we'll skip the review day on Thursday so we can do the test.